Welcome back. We're continuing our series of conversations in the risk engineering space. And we've already had a battery energy remote monitoring service. We've had a robot fireman. And today we're going to have a guest and his team talk about control of work in power and chemical plants. I'd like to introduce Aaron Callaway. He's a software executive. He focuses on business continuity, disaster recovery, operational resilience, crisis and emergency management, and integrated risk management. Aaron, would you like to introduce your team?
Hey, John, thank you so much. Honored to be on your podcast. I've become a quick fan of yours. I love the fire robotic session that you did. Some really amazing technology that you're putting on display. So really cool to be part of your podcast series here. I'm Aaron Callaway, and my background here, it's a little bit different than maybe some of the risk managers that will be listening in on this podcast. My career really started out as being a consultant. So a software implementation consultant looking at large enterprises and looking at efficiencies, looking how to provide better outcomes. And a lot of times working in some of the manufacturing sites was looking at health and safety. Health and safety for me as a resiliency professional is certainly keeping people alive and safe, but it's also creating an efficient work environment, right? If something goes bad, it's going to slow down production. And there's also health and safety issues, but then there's also financial issues that go along with this. So it's a win-win opportunity here to really embed health and safety into the operations of organizations. And specifically where we're focusing in on today, it is around the utilities, oil and gas. And so taking that resiliency lens into health and safety, just talking with some friends of friends really brought me into this area and looking for opportunities to leverage modern technology, ways to configure technology to work for you and not vice versa. This whole thing about artificial intelligence, it's a thing. How can we take something from academic to reality and bring it to the front lines of really where it matters? And we're not talking about robots taking over control of work. What we're talking about is AI helping to create more efficiency, more reliability. And the technology is there today. And it's helping to create these recommended steps that someone approves and puts into action. And so I'm going to slow down from there and I'm going to introduce our technology business architect. And then I want to pass it over to Steven Shutt, who is also a senior technology person that's been in this space a long time and really has been very influential in our direction that we've taken within control work. So Steven, I'll pass it over to you.
I'm Steven Shutt. Glad to be here, John. Thank you. And thank you, Aaron, for the introduction. My background is I've got 35 years plus of oil and gas experience. My experience started back in the late 80s in a refinery in Texas City. I was an operator and shift supervisor, so I have a lot of operations background where I cut my teeth, and that was with the company called Amoco. BP purchased that facility years ago, and I worked with BP, which was a whole different operation system and management system. And so I helped them with that part and getting into what we call operational risk and risk assessment. I was the senior person in the group with that, sort of technical authority. After that, Marathon purchased the refinery back in 2013, where I was a safety manager. And then I went on to be a corporate auditor. I was a management system safety and security auditor for the company. And I was able to travel all over through all aspects of upstream, midstream, downstream, and even retail and doing management system auditing. And so I've got a wide range of experience. I retired earlier this year and started my own business as SDS Safety Services Incorporated, where I'm helping companies like Control Work and Aaron to help just use my subject matter expertise to try to help with the direction and help reduce risk and make things safe.
Awesome. You've sort of told us a little bit about your journey and what led you to create Control of Work. Can you tell us what problem in the control of work space you were most eager to solve?
John, first of all, when Steven became a free agent, it was like a blessing for us to really bring together some of the top technology people that have been in this space, have done this as their passion for their career, and really helping to guide us within our technology. So really the biggest challenges, and Steven, I'll let you add to it as well, is control of work. It's still many organizations are still on tablets, right? Still a paper-based process, still moving that along and thinking that's just good enough because that's the way they've done it in the past. And change for organizations is sometimes tricky. There's certainly elements of technology that may have prohibited it from going into the field in the past. And now technology is caught up, like with cellular technology, having different mobile capabilities that actually doesn't require cellular, that we can capture the information and then when cellular comes back into play, push it out there. The technology is there, modern technology there, where it's meant for people in the field, right? It's not meant for a desktop. It's meant for people in there. And as we go through the demonstration where we can leverage like just taking your camera, taking a picture of equipment, taking a picture of a QR code, keeping it so simple that it actually speeds up the process while also creating a safer work environment. It's like a win-win. There are some technology that's been out there today, and working with other advisors, that technology, it's a little bit dated. It's hard to use. It's not really configurable to different types of environments and specific. And that's where I said, we want the technology to work for you and not vice versa. And having the people in the field own this process and help them. So that's really, in a nutshell, there's a lot of components that I put out there, but that's really what drew us into this space to solve those problems. Steven, what do you think?
What you just talked about, Aaron, was outdated systems that are already in place, right? And I was a part of that. I was the control work technical authority for a major company. And the reason that company doesn't use it anymore, or the new company that purchased it doesn't use it anymore, is because it was not configurable. It was not easily configurable. And it didn't have AI, right? So there was no way to use today's technology to incorporate into it to make it work better for you and safer and quicker and more efficient. So that technology, because they weren't able to make those changes and come up to where we are now, they're not doing it anymore, right? We've been down this journey, and now I'm excited to know that I'm part of a journey that's using new technology to make things efficient and more safe.
I know what you guys mean. We'll get into what you guys define as AI-driven control of work and some real-world examples here in a second, but I wanted to give you a real-world example of where I'm at. I've seen AI taking a picture and having it do the fire protection engineer's job. We had a facility that was being inspected by our insurance company, and the engineer was concerned. He saw some stacked IBCs, these big boxes full of oil, and they were 3 high, and just something seemed wrong about that to him. He went over to the sprinkler riser, took a picture of the hydraulic placard to get the design density of the water supply for the sprinkler system. And he sent those pictures back to his fire protection engineer in corporate. He copied me on that email, and I had the pictures. So I just put them into AI and asked, will these sprinkler systems control a fire involving this hazard? And it said no. It gave me the code references. It told me the design density that the placard said they had, told me the design density that we actually needed, gave me some suggestions to improve it, and said that you can either increase the amount of water, which then you had to worry about drainage. Where's all that water and oil going to go? Or you could add foam to it and use the existing water supply and not have to worry so much about drainage. So it was just phenomenal. But I realized, holy crap, people aren't going to need fire protection engineers pretty soon. So you guys touched on the AI. How do you really define the AI-driven control of work? Where does it get in besides taking the picture? What else are you looking at? Are you able to look at trends? Are you able to compare one plant to another? Just how far does your AI reach?
Yeah, we're just at the tip of the iceberg right now, and we're taking a measured approach, and we want to get the basics right and automate people out of paper and move away from legacy technology that the people in the field don't like using. So we know that we need to get the basics right. We're incorporating elements of AI that we'll actually show you in the demonstration, taking a schematic, loading it into our AI, and it will recommend very specific steps that you need to accomplish or perform a lockout tagout. Now, within our technology, we just don't push that out. It needs a human in the loop. It needs to be reviewed and approved to move forward, but it sets the stage around what good looks like in the beginning, and then it goes through the approval process and it's pushed out to the field. It increases efficiency, increases speed, it increases the probability of a safe working environment. Steven, anything else you want to add to that?
being somebody that's actually done control work on paper and electronic, the electronic is just amazing because it helps you get that in the field and also be able to help you, or the person out in the field does not have to run back and forth trying to get paper every single time they need to make a change or get an approval. There's using technology now where you can just get that approval by sending somebody a message and making sure that they know it's in that next step. But the main thing with control work is it's just that systematic approach to making sure that you're not missing anything. It's taking your plans, your risk assessments, your steps, and putting it all into one place so you can manage it. And it just doesn't work very good on paper.
Right.
When you have an electronic flow that you can flow through the system and use in the control room to make sure that you're not missing anything. And then on top of that, adding AI to make sure that you've got a robust look at everything, not only just what your procedures are and your P&IDs, but also what's happened in industry and what's making it safe and what you can look out for is just amazing.
It is. I remember when I worked at a nuclear power plant early in my career, and we were having trouble with steam leaks on valves and the valve packing. It depended on who went out and worked on the valve. They might just throw another packing ring on top, and they continued to do that every few months as the old rings wore out. Well, where are all these old rings going? They were going down into the system. And that's not good to be shoving all that crap down into your supposedly pristine water going through your nuclear reactor. We had to go back and look at a paper trail of maintenance work orders to find out, what did the last group do? What did the group do before that? Did they pull all the packing rings out? Did they count them? How many did they pull out? And why did they only get 5 if there were supposed to be 7 in there? So that was one of the things that I remember about the paper world that wasn't great. But even worse, at that nuclear plant, one day we had an incident where this was a chain of things that went wrong. A crane operator on the turbine deck was moving the crane from one end of the turbine deck to the other. There were lockouts to prevent him from moving across the roof of the control room. They overrode those lockouts because it was so slow to go over, back and over. They were going straight across the control room. They had a chain fall hanging down, which banged into an air pressure gauge on a fire protection system, causing that fire protection system to trip. That system protected a charcoal filter train that kept the air clean in the control room in the event of a nuclear accident, so that the operators could stay and safely shut it down. With water flowing in there, the years of vibration, the charcoal had just basically shaken down into the drains. So this water filled up the ductwork, went out and spilled into the control room. We're getting to the control of work part. You're going to hear it in a second. The water spills onto a relief valve, 12 relief valves in this plant, and they cause this relief valve to pop open. And if you can remember what happens when you spray a pressurized can of liquid or gas, it gets very cold. So that's what was happening to our nuclear reactor. It was getting very cold very quickly. We exceeded the cool down rate of the design for the fuel. And what fuse did we need to pull in order to close that valve? They needed to go find this fuse. The as-built notices that would have shown them what fuse to pull were on the shift supervisor's desk waiting to be signed off. And so for a long period of time, we exceeded the cool down rate of this fuel. And it was so bad that we had to disassemble the reactor, take the fuel out and inspect the fuel for cracks. We almost had a 3-mile island over this. And it was because a drawing was still waiting to be signed off before it could be live. And so long story, but control of work in those days was sketchy.
Amazing.
You're going to walk us through a real world example here? Okay.
I got an example first because when I was presented this by Aaron, what are we going to do? And he's like, well, we're starting with lockout tag, right? And so lockout tag out is just a system to make sure that anything you're working on has been shut down, de-energized, isolated, locked out into a state where someone can't inadvertently or on purpose open up a valve where it could reintroduce energy and injure somebody that's working on equipment, right? So that's what lockout tagout is. Now, how do you do that with control work? And how do you do that electronically? You follow that workflow process. You incorporate all the steps into the electronic system. Where I have a real world example of this is how it's better than paper. When I was in the role of the auditor, I was at a terminal, a fuel terminal, which is a location that brings in barges full of gasoline and they put it into tanks and bring it to all your local gas stations, right? So We were in a very large metropolitan area where this one terminal supplied probably 20% of the gas for this whole metropolitan area. So it was quite a bit of flow going through it. I asked to witness an isolation. It was taking place very early in the morning. Operators had already isolated it. A supervisor was taking a paper list and going out in the field and walking them all down. He took his paper list and walked every spot down. Operator had done every spot that was on his paper list properly. So they were all good, right? They said, okay, we're going to take a break and we're going to do a cut on this line. They were using water cut. So it's a cold cut. It's about a 12-inch line. And they were going to cut this line so they could add a flange and put a valve on it. Right before it happened, I asked the operator, I said, can we just walk through this lotto so I can see it myself before you guys make this cut? And so we went out and actually walked the lotto step by step. And when I was out there walking it, I identified a valve that was not on their isolation list and was still open. And I asked about it and he's like, no, there's no way anything can get in there. I said, well, if it did, it would go out the vent that should be open, which they didn't have on their list either. So we walked back over and they opened the vent and it sprayed gasoline out of it. Okay. So they were about to make this cut on a line that's now full of gasoline because this valve was missed. Luckily I was there and luckily I walked through it because they would have cut, right? But you think about what could happen if they would have cut, right? If they would have cut it, you would have definitely had a gas leak, potential fire, potential explosion, potential people being even bigger. If it damaged a large portion of this terminal, you'd have an area in this metropolitan city that doesn't have access to gasoline to their gas stations, right? And so you can imagine that chaos. And then on top of that is the reputational damage that could cause your company. It'd be all over the news, right? Everybody would be talking about how somebody didn't do their job, where control work this electronic version of this, right? And the process would have, if you would have asked AI and uploaded a PNID and your procedures, it would populate that valve would be on there to be closed. And also you would have it go through a system to where you don't miss the approval process of your plan, where somebody else goes out and checks it before you use it. And it's not just on paper, right? Where somebody could miss something, which is what happened. So very, very, very lucky I was there. And I'm glad that, that I can share that story because.
Yeah, you're here.
Yeah.
You're here now to share it.
That's a great example of the real life. And we're all human, right? No one wants to hurt someone. No one wants to be hurt. Sometimes we have bad days, right? But any times that we can leverage technology to make us better, right? We're not going to replace someone out there repairing pipelines, working on telecommunications, but it's there to help support them and do their job better and more efficiently and safer. That's a key part of what we want to accomplish here.
You remind me, I was in a refinery and I'm a power generation engineer is my main background. And going into refineries, it's a little spooky because they're used to having fires and we weren't used to having them in power plants, but they have big fire brigades and they have complicated processes and a lot of chemical reactions. And I remember during a break in the conference room, I just walked over and snapped a picture of a process flow diagram. And I asked AI, explain this drawing. Golly, did it give me a great explanation, all the steps of the refinery. And I thought, holy crap, we're not going to need risk engineers pretty soon because these things will just be able to write the risk engineering reports for us as well.
Well,
So-
yeah, it'll just make the job slightly different.
It is. I'm making fun of it. It's not like it's going to take our jobs, but it's going to make us much better, much quicker, and more confident, honestly. I think that it felt a lot better after they were showing the different constituents of the refinery, showing the different products that they refine their crude oil into. And I snapped a picture of the slide during the presentation. And when I said, explain the slide, and it went through and it told me all the financial metrics of each of their products, told me what the current market price was of these chemicals. So I actually had more information about that slide than the treasurer who was sitting next to me, and certainly more than any of the engineers that were there to evaluate the plant, and told me what the bottlenecks were, what the flow rates were. And it was just, wow, you can learn so much just by taking a picture.
But the other thing with that, when you start talking about using AI, it's like a safety professional, which was what I did most of my, is trying to convince leadership that you need to spend money to prevent somebody from getting hurt, right? And so they only see dollar signs. They know they want to keep people safe, but they see dollar signs. You can now use AI to show you what that dollar sign really is and not just take a spitball guess, right? You can look at different units, different areas, and how long they're down, and what's the average of money it's going to cost for that unit to be down if there's something does happen, right? So those damages, and like this slide, the damages easily exceeds $1 billion. You think many units are more than $1 million every day that they're down, and unplanned downtime is just crazy. Safety, how many people get hurt, and also your regulatory compliance, right? You look at the regulatory aspect. I've had a lot of dealings with OSHA. I came from a refinery that OSHA visited quite a bit because of an explosion that happened in 2005. I worked with OSHA. They had an office right next to me, so I got a lot of experience. And they are busy writing citations, right? They cite people for everything from fire extinguishers to not following your procedures, right? And everything else in between. And having something that, like, we talk about control work, is how do you incorporate all that stuff into one system?
Right.
And this does that. You can bring that in to make sure that you reduce costs for that downtime, you reduce costs from not getting fined, and you keep people safe.
Yeah. So what AI technologies power your platform? I'm pretty sure you're not uploading pictures to ChatGPT. So do you use API keys? Do you have something proprietary? How do you implement your AI?
Yeah, our AI is proprietary. We put a lot of work into designing it and configuring it. That's probably for another conversation, John. Our technology, it's meant for this specific use case. It's meant for specific lockout tagout. It's meant for oil, gas, and utilities, so that it's smart, it's refined, and that it's in a controlled environment. That's why we think that it's the right assistant to help these organizations do things better, quicker, safer, faster. And the other point that, John, I wanted to piggyback on your story from the nuclear plant is that this system tracks everything, like tracks these steps that are required to be tracked, right? It approves the steps that need to be approved. So going back and checking out the prior history of what was done or what wasn't done, it's all in there, and it's easily, that can be reported upon. It can be walked through. If a regulator asks for this stuff, it's not going through papers and putting up a whole project to get ready for an audit, right? And this is audit ready. So you are ready, and bring on the auditors. Let's get this through and really form a good relationship with that team and with other risk managers, and how you can do things better.
Fantastic. So how does it integrate with legacy systems? Do they have to start from scratch? Is there a way to upload any kind of history? And how is that process for end users?
Great question. Our technology is built on a platform called ServiceNow. It's one of the largest software service providers in the world. Many oil and gas utility organizations leverage ServiceNow already. We're basically like a module that you can turn on. And if you don't leverage ServiceNow, that's not a problem either. We can bring that in as our standalone product. So it's a tried, secure, globally accepted platform. And so within that platform capabilities has immense integration capabilities. So if you're using like SAP for your work orders, we integrate with SAP. A lot of these other technologies that are out there, have these spokes that are already deployable. So we can leverage those already today, and to bring in that information that is in existence within the organizations today. Or if we want to start from scratch, we can do that as well.
Interesting. And so what level of change management is required with PSM facilities? I know Steven will know what I'm talking about. Has there been any issues with management of change documentation?
I haven't seen any yet, but you definitely, whenever you're going to change a program from paper to electronic, you definitely have to go through a management change process, right? So that's a requirement. And that way you don't miss anything. And that a lot of times when you do that initial gap assessment, even before the management of change takes place, you'll identify where some of those holes are, where you're missing some items that are required. But yeah, the management of change system is just a requirement that's got to happen.
Okay.
Yes.
And
So,
Steven, you've been part of one of those before, right? I understand. This is why I love this technology is that when we present this to people in the field, they're like, bring it on, but they need to own it, right? You can't just, it's not about forcing someone to do it. It's about bringing this into the organization, having them being part of input into how the system, and that's why it's tailorable for their specific steps and requirements for lockout, tagout. Having them adopt it and use it and understand it's really important also.
okay.
And the key, what we talked about earlier, is about how it can be changed to whatever company you have, right? So you can make changes to this to make sure that it follows your company's process and steps. It's configurable. And that's really what my last control work experience, again, that was not configurable. And so you had people that weren't really happy with it from everywhere, from the people in the field, the operators, the technicians, all the way up to upper management because of the cost and time it took to configure. But that's why this is so good for even utilities and small companies, is that you don't have a lot of experience with management of change at some of these small places where there's a small, like 15, 20 employees. They don't have a lot of experience with it. So when they go through that process, it's really easy when you have all this data that can help support it.
Yep. Our procedure for design control at the nuclear plants that I worked at, one of them, it was 175 pages long. And I remember going into some of these little knockout fractionation plants and asking them about their management of change. And it's a little notebook over there, a log, and they review it every now and then. And they probably fill it out right before their PSM audits. You're right. There's a big difference in how they operate. What about results? I've asked the firefighting robot and the battery energy storage monitoring company, have you had any saves? So can you point to anything results wise that the clients can see that they're actually getting something not just different, but better?
Yeah, where we are in our journey is in the development and deployment within our client base. We're taking people from the paper process into the electronic environment. And so we're pushing these systems out too, right? We launched this product back in May. And so now we're in the deployment phase. So organizations are adopting it, implementing it, and helping to provide feedback into what they would like to see in their environment. So we are starting to see some of those beta type test scenarios play out, and people are seeing the benefits of putting this into the ServiceNow environment. And I think the other piece that I didn't really highlight before about why we chose ServiceNow, not just because a lot of these utilities and oil and gas organizations already have ServiceNow, but they also have capabilities on ServiceNow called field service management. So they are out in the field working with some of these people today. So we can leverage field service management, some of the integrated risk management capabilities that is also built on ServiceNow. So there's just more reason than leveraging a platform like that.
Okay. Gotcha. We're going to talk about a couple more topics. And I just want to clarify, did you have a demonstration you wanted to run?
Yeah, we've had so much fun just chatting.
Yeah.
Yeah, so let's jump over to that, and I'm going to stop sharing here.
Hey, thank you very much for allowing me to give this brief demonstration of control work isolation application, which includes this amazing AI integration. And of course, it's all powered by ServiceNow, which is really great due to their experience in this field. What I want to start with is just showing you all a dashboard. This dashboard is a really helpful tool because it has everything all in one place where you can look at your plant or your unit and see what isolations are in place or what stage they're in, even history if they've been deleted or completed. I was a shift supervisor before I became in the safety department and a safety professional. Whenever I would come back from my weekend off or on vacation, it was very important to me to know what isolations we had going on out in the field and for the safety of my crew for me, but also for the work we needed to do. But what I had is I had paper, right? Well, we had to go grab a binder off the desk and thumb through it to try to find out what stage or what isolations we had or what stage they're in. Here, it's all in one place. It's just really helpful. And as you can see here, you can see everything, right? So you can see long-term isolations. If we have any amendments in place, what are all the isolations? We even have a pie chart here that shows what stage they're in, and you can click on any of these and get a list of each group. And also here we have MySpace, which, we're not talking about the old app or the old social media page, but we are talking about mine. What do I have to do? So what's on my plate today? And so in this instance, let's say for the whole plant, I've got an isolation in progress, one that's awaiting verification, and one that's de-isolate for test. So I could open these up and look at those different isolations. We also have drop-down menus here, like equipment, location, what state, or even if you want to search for a date range. I start looking back here at the list view. So that's just another way to look at it. If you don't want to look at the pie chart, you can look at the list of all the isolations and what stage they're in. And then you can also filter each column. Let's say from high to low or low to high, as far as the numbers or equipment or site, and you can look at it that way. We also have a My List, which is just a favorites. We've created these favorites so that I can, instead of looking at all the lists, I can come over here and say, what's waiting authorization or what's assigned to my team? That's what I'm going to look at when I come in. I'm going to say what all is assigned to my team. And I'm looking down here, and the second one is this diesel generator. I know that there's been some communication this morning during the shift relief that says, hey, we've got this diesel generator, the hot item. We got to get it going. So I think we got to pull that one up first. When I open up this isolation request, you can see there's a lot of information here. There's the isolation number, the state, the stage it's in, the title. This is a diesel generator. It's got the number, lotto for maintenance. There's even a description to ensure that this isolation ensured the safe shutdown of the equipment, reason for the isolation. The other thing is that here you got the isolation plan. These are the actual isolation points and the types and the method and what state it's supposed to be in and what state it's going to be in when we put it back in service. We even have risks that we have here and instructions. And then we can also print all points where we can get tags for isolation points out in the field. When we click on that, you can see here that these have QR codes along with naming the piece of equipment, what type of isolation it is, and the isolation control, the request number. You actually have a QR code so you can use your mobile device, whether that's the cell phone or if that's a tablet or intrinsically safe piece of equipment. And you can take a picture of this QR code and show that this isolation point has been isolated and in place. And it'll allow you then to go in and take a picture of the isolation. Very helpful for remote work. There's this AI chat now. That's where all the magic is, right? So it's a helpful tool to help you do your job because it's more efficient. When you pull up this AI, and let's say you're going to be trying to create an isolation plan, you want to ask a question. So can you provide a step-by-step isolation plan for this equipment based on this PNID? So you can upload the PNID, which I did. Now, want to make sure you understand that this does not eliminate the need for people to go verify this stuff. As you can see here, it's given us some information. It gave us pre-isolation steps, main isolation sequence, upstream isolation, downstream isolation, depressurization. It even gave us these safety monitoring requirements. We're going to continuous gas monitor, regular pressure verification, additional precautions. So we want to make sure we read this and we use this as a tool to create our isolation plan. And you can also use this to ask the AI to give you some instances where there's been incidents in the industry with this type of isolation. It'll go back in and search and find out specific incidents that have happened where an isolation of this type has caused issues. And it'll give you even lessons learned if they can find them and all that good information.
Fantastic. Wow.
It's pretty specific there, John, huh?
Yeah. It just always amazes me. No matter how much I use AI, it still amazes me.
But the key to this, though, is that this is the starting step, right? So you still want to take this and you're taking it to go out in the field to verify that it didn't miss a step and then make sure that the PNID was actually accurate, which they're all supposed to be accurate with changes through the management of change process. But sometimes you may get an old PNID that's missing a valve or something, and you want to make sure that this is accurate before you actually get it approved.
Right. I gave a presentation on risk engineering applications for AI. And one of the questions was, how do you prevent garbage in, garbage out? And I said, in the old days, 2 years ago, for AI, they were trained. You basically photocopied an encyclopedia and then you could look up questions in the encyclopedia, but it was only good for what it was trained on and it would hallucinate. And nowadays, we also have research and chain of thought so we can look and see how the conclusion was drawn. What were the steps of reasoning before it gave you the answer? And I know that in the early days, we would count on the user of that AI document actually being an engineer or an operator or somebody who could look at the output and say, yeah, okay, that makes sense. That's good. I'm going to use it. I would have got to the same place. It would have taken me a few minutes longer or an hour longer. And nowadays, with not just the chain of thought, but research, it's able to go out and look at other sources. Not sure that proprietary models have that built in yet or not, but that's just something for the folks that are worried about garbage in, garbage out. It's going away, I believe.
Yeah, that's a great point, John.
And you think about the ease of mobility. If you take this and you put it into the isolation plan, the certificate that was on that last page, and you go out into the field where paper, somebody would have to go to a binder, try to find a piece of paper that's supposedly had an isolation plan and go out in the field and try to isolate, or they would go out in the field and just isolate and try to write down what they isolated. This way, they can take a pad, electronic pad with them out in the field. And once it's ready for isolation, after it's been authorized, they can actually take that plan, go out in the field with their tags that you can print out from this document with QR codes, and go out in the field and isolate those steps. And then and if you're remote, this allows you to use the QR codes on your electronic device to verify that they're in place, and then take a picture of it to make sure that it's shown that lock is in place, the cable's in place, the valve is closed, just in case you don't have a second person to go out there and do a physical verification that it's in place.
That's fantastic.
And so, yeah. And
So is there a permissive involved with that? Does the AI say, no, you can't continue if it doesn't sense that the lock is locked?
the software,
Right.
not the AI. The AI is telling you what it needs to have, but the software you put in your workflow to make sure that those interlocks are in place,
Okay.
to make sure that takes place.
Yeah, John, the technology will get us there as more of the manufacturing. Maria, continue on. I do want to highlight one thing is that we want to keep this simple, right? It's a complex process. And I believe the power of technology is to create something complex and make it simple, right? All the complex stuff should be behind the scenes. The data is super important. And then how do you create it intuitively and simple? And so we laid out the exact isolation steps up at the top. So you know where you are, you know what you need to do, what you've done, and what you've been successful at before. But as Steven mentioned also is that these 11 steps may not be the exact steps for every organization. So we can sit down and say, okay, what do you need to have specifically within these steps to make sure that it's right size for your organization? So just want to mention that on the configurability of it.
So what about working with risk engineers? That's who most of my viewers are, risk engineers. You said you just got started in May, and I can think of a lot of risk engineers that are going to like to see this, especially the ones that do the chemical manufacturing facilities. Have you had any interest yet from that industry or anybody ready to benchmark or look at the platform from insurance?
Yeah, that's one of the earlier conversations we were working. Chemical process, and the risk manager of them, she was so excited to introduce us to her outside risk organization. One, because she's proud of leveraging new technology, but also she viewed them as peers, like collaborate together in making sure that her chemical processing plant was state of the art and leveraging the latest technology. As we push out, and John, that's how we met, right? Is that we're getting the word out and people are saying, hey, can I take a look at this? We feel very fortunate that there's been about a dozen risk managers that have already reached out to us and inquired about what we're doing and how we can help accomplish the things that we're talking about.
Fantastic. Where do you see the future of control of work ecosystems heading in the next 5 years?
Yeah, there's two ways we can go. We can talk about our roadmap, or Steven, I can pass it to you.
But I'm excited for it the future. It's not just lockout tagout. It's additional things that this can do, right? It's anything that's life safety from my aspect, anything that's life safety, safe work permitting, job hazard analysis, procedures, SIMOps, making sure that you can use technology to make sure that when you're writing a safe work permit, you don't issue a hot work permit near where you've got another permit for opening up or what we consider invasive work, right? You want to make sure those two together are in the same space. So technologies can be put in place to where you keep a buffer zone from each type of work that's dissimilar so that SIMOps can be maintained. It's not just about, hey, I think I have 15 permits out there today. I don't know which one is which, but so I hope these guys are just on break. And if they're just on break and they're not there at the time when I'm ready to start this work and they come back, now I could have a problem, right? And so looking forward to using the electronics for permitting, controlled twin or digital twin, and also SIMOps.
Well, that reminds me, my fire protection buddies will all be thinking, will we be able to control hot work permits in areas where fire protection systems are impaired?
Well, you can, it just takes extra controls, right?
That's one of the things that they would love to see is just some
those
automatic
controls. That's all part of that risk assessment. So anytime you have a high risk situation where you've reduced some of your other controls, you need to get together with management and sit down and do an actual risk assessment. And in this case, you can actually ask AI, how did this happen in the past? What happened in the past when you've done this hot work in an area where we've reduced the fire protection system, right? So you can ask AI that question. But making sure that the risk assessment, so making sure that you've sat down and had this conversation about, hey, if we do this, what could happen? What other controls can we put in place to make sure it doesn't?
Great. So, do you see AI playing any role in future EHS or maintenance programs that we haven't really touched on today?
John, you can't say no.
Right.
I went to a state school, so my double negatives are great. But as we look into it, like we look to leverage this AI, like it's all like kind of revolves around the platform and the technology that we're building upon. Lockout tagout is the foundation, right? We see huge opportunities to build these better togethers across this whole control work, permit to work and ecosystem. We want to stay in our lane. We want to be the best at what we do, and help the health and safety and operational risk managers that are out there, and really do it in these 4 buckets. Gen IA first. Yes, we're not playing Star Wars here. We want to use it effectively, efficiently, and safely. I'm going back to, we need to get the basics right, and Gen AI will make us better. You mentioned about the integration, leveraging some of the existing platforms that organizations have in place today. That's where our integration and real-time integration comes into play. As I mentioned, we're built on ServiceNow. The odds are these organizations already have it. So it's not about buying a different technology solution. It's a technology that's in-house today. And then recognizing that, mobile is a must. It's a must do for people in the field in tablet form, in mobile capabilities that are out there to really make sure that people can do their job. Yes, safely is key number 1, but efficiently, and them feeling good about how they're leveraging it.
Awesome. Well, we're about to wrap up. Aaron, could you bring us home and let us know how folks can get a hold of you and potentially contract y'all for some service?
Yeah, well, John, you're a good man. I really appreciate it. Ultimately, yes, we want to service clients. We are passionate about what we do. I'm really excited about this opportunity. And as we went through this whole thing, we talked about lockout tagout as our kind of foundational starting point within the control work environment. We're looking to leverage AI in a very smart way. We'll grow upon that and how we can make things better, leveraging tech AI with a human in the loop capability, visibility, reporting, auditability, like all these things we can make simpler so that we're not always running uphill we build upon this momentum and working together with our risk managers, working together with our auditors, because we're not afraid about the amount of effort it will take to report back. We're clicking buttons, right? Because we're capturing this information along the way.
Awesome. Well, what about the ways to reach you through LinkedIn, through your website?
Yeah, LinkedIn is great. So controlwork.com is our website. That's my email right there. I'm also on LinkedIn, and would love the opportunity for people that are curious about how we're doing this today and just having these conversations. We're continuously learning. We're not perfect. We want to help organizations that are looking to move their health and safety program to the next level.
Awesome. And I know there's some out there that need help moving. So I'm going to pass along.
I want to thank you, John, for this opportunity. It's been great to get to know you. And Steven, thank you. Working with industry experts like Steven is crucial to bring this to market. Having that hands-on experience and knows what it takes to take technology to the field is super important. Technology is just a piece of the puzzle. It's everything else that really makes it happen.
Fantastic. And to all the viewers out there, YouTube tells me that 75% of you are not subscribed to my channel, believe it or not. That's pretty common on YouTube content. So go ahead and click like and subscribe. It'll get the video out to more people that definitely could benefit from it. So thank you very much for watching.